Welcome to the video on circles, radians, arcs, and sectors. First, we'll learn about radians. So a radian is the angle formed when the arc length is equal to the radius. So this is the length of your radius, and if you took it and wrapped it around your circle, once it equaled your radius, then this angle here, theta, is going to be equal to 1 radian. So there are 2 pi radians in a circle, and radians can be measured as fractions times pi, or whole numbers times pi, as well as decimals. So 2 pi over 3 radians is approximately 2.094 radians. To convert from radians to degrees, you'll multiply by 180 degrees over pi radians. And to convert from degrees to radians, you'll multiply by pi radians over 180 degrees. So if I was given an angle of 45 degrees, for example, and asked to convert it to radians, you would do 45 over 1. We want our degrees to cancel, so we'll have 180 degrees on the bottom and pi radians on the top. So then you could multiply. Both of these can be divided by 5, so you could get 9 over 36, and then they can both be divided by 9 to get 1 over 4. So this would be pi over 4 radians. And then if we were given something like 5 pi over 3 radians, we could convert to degrees. We want the radians to cancel, so we'll have radians on the bottom. So pi radians, and then 180 degrees on top. Our pi can cancel. 3 and 180 simplified to 60 and 1. So then we have 5 times 60, which is 300 degrees, because our radians cancel. So that's how you convert between radians and degrees. So arc length is the length of an arc enclosed by an angle. So over here, this red portion is our arc length for the angle theta. You could also do this angle on this side, and your arc length would be this entire other portion of the circle. So to figure out your arc length, you need to figure out what proportion of the circle your angle covers, and then you need to multiply that by the circumference. So in degrees, your arc length will be your angle out of 360 times 2 pi r, because this would be what proportion of the circle you have. And then this right here is your circumference. So for example, if we had theta equals 20 degrees and r equals 4 meters, we'd have 20 degrees over 360 degrees times 2 pi times our radius, which is 4. So 20 over 60, you can divide both by 10 and then by 2 to get 1 over 18. So you have an 18th of a circle times 8 pi. Our 8 and 18 can simplify to 9 and 4. So we get 4 pi over 9. And this would just be meters because we're measuring length. So 4 pi over 9 meters. So then if we use radians, our arc length is going to be theta in radians over 2 pi times 2 pi r. Our 2 pi cancels, so it's really just theta times r. So if theta was pi over 5 and r was 15, then our arc length would be theta, which is pi over 5, times r, which is 15 feet. 15 and 5 can simplify to 1 and 3, so it would be 3 pi feet. So that's how you find your arc length. Next, we have the area of a sector. The area of a sector is the space enclosed by an angle. So now we're looking at the whole area here and not just this arc. So for this one, we're finding the proportion of a circle and then multiplying it by the area instead of circumference. So in degrees, the area of a sector is your proportion, so the number of degrees over 360 times pi r squared, because that's your area. So for this example, we have 20 degrees and 4 meters again. So our 20 degrees over 360 times pi r squared. So this simplified to 1 over 18. So we have 1/18 times 4 squared, which is 16 pi. This simplifies to 8 over 9. So we get 8 pi over 9, and since this is area, it'll be meters squared. In radians, our area of a sector equals theta in radians over 2 pi times pi r squared. So that simplifies to theta times r squared over 2. So we'd have theta of pi over 5 in this example times r squared, so 15 squared over 2. So that will equal pi over 5 times 15 squared, which is 225, all over 2. 225 and 5 simplify to 1 and 45. So we have 45 pi over 2, and our units are feet squared. So that's your area of this sector. So here we have our first IB practice question with a calculator being allowed. It says, Jerem is wanting to eat a piece of pizza. A 16-inch diameter pizza is cut into 8 slices, and a 24-inch pizza is cut into 12 slices. Which pizza should Jerem grab a slice from if he wants the larger piece of pizza? So we'll draw our 2 pizzas. So this is pizza 1. And we'll draw pizza 2 over here. So pizza 1 is a 16-inch diameter pizza. So this is 16. So our radius is 8 inches. And it's cut into 8 slices. So it looks like this. So we want to know what the area is of one slice of pizza. So if we think about our proportion, we have 1/8 of a pizza times our area. So pi r squared. So 8 squared. So that's 1/8 times pi times 64. 64 and 8 simplify to 1 and 8. So this is 8 pi inches squared. So you could also figure out what each of these angles is by taking 360 and dividing that by 8. So we could find that each angle is equal to 45 degrees. And then you could say 45 degrees out of 360 degrees, which will just simplify back to 1/8. So for pizza 2, our diameter is 24. So our radius is 12 inches. And it's cut into 12 slices. So it would be something like this. So we want to find the area of one of the slices. So we have 1/12 of the pizza times pi r, which is 12 squared. So this is 1/12 times pi times 144. 144 and 12 simplify to 12 and 1. So this would be 12 pi inches squared. So if Jerem wants a larger piece of pizza, he would want to go with pizza number 2 because one slice is 12 pi inches squared instead of 8 pi inches squared. So we'd write Jerem should grab a slice from the 24-inch pizza. And that's your answer. Now we have our second IB practice question. It says in the figure to the right, AD is the diameter, BC is the radius, and is 8 centimeters long. So BC is 8 centimeters. And the measure of angle BCD is pi over 4. So BCD, this angle here, is pi over 4 radians. So we can tell that it's radians because it doesn't have the degree symbol. So then you automatically assume it's radians. And also if it has pi in it, it's typically in radians. So this says find the length of arc BAD. So we're trying to find this arc length. So our arc length is going to be our proportion of the circle times 2 pi r, because that's our circumference. So we need to know what this angle is to figure out what proportion of the circle we have. So in an entire circle, you have 2 pi radians. So our angle is going to be 2 pi radians minus pi over 4 radians. So that's 8 pi over 4 minus pi over 4, which gives us 7 pi over 4. So that's this angle here. So we have 7 pi over 4 out of our 2 pi times 2 pi times r, which is 8 centimeters. So our 2 pi can cancel. So we're left with theta times r. So 7 pi over 4 times 8. 8 and 4 simplify to 1 and 2. So we get 14 pi, and this is going to be in centimeters. So here is your arc length. In summary, a radian is an angle that's formed when the arc length is equal to the radius. There are 2 pi radians in a circle. To go from radians to degrees, you multiply by 180 degrees over pi radians. To go from degrees to radians, you multiply by pi radians over 180 degrees. Our arc length is the length of an arc enclosed by an angle. In degrees, it will be theta over 360 degrees times 2 pi r. And in radians, it'll be theta times r. The area of a sector is the space enclosed by an angle. In degrees, it'll be theta over 360 times pi r squared. And in radians, it'll be theta times r squared over 2. That's all for this video. Thank you for watching.